Action. Okay, so we got three different forms: slope-intercept form, general form, slope point form. What we do is 96% of the time, we will be starting in slope point form, okay? Probably only 4% of the time, if that, you'll actually be able to start in slope-intercept. And the only way you'll be able to start in slope-intercept, if I tell you the intercept, okay? Then you can start there. Very, very rare. And if you don't recognize it, you can always start here and then change it. What we do once we're in slope point form is I'm going to ask you to write it and change it into general form. So if I ask, hey, what's the general form of the line? You can't tell me until you start here. Or if I ask, what's the slope point form of the line? You can't tell me until you start here, and then you change it over, okay? You can go from slope-intercept to general form. You can do that very easily, and you're going to be doing a lot of that. But you can't go into slope point, okay? You can't, from slope-intercept or general, you cannot change it into slope point. You can only start there, all right? Now, what's the rules for general form? So general form, you also have the two rules of general form, which I just talked about. Number one is you can A must be positive, okay? So A must be positive, and the second rule is no fractions. So we will be multiplying by a common denominator to get rid of our fractions. Okay, just a quick little trick and skill. All right. Sometimes what you're going to see in some older books and on the internet is you might see this thing called standard form. We're not going to specifically talk about it, but just to let you know what it is it's kind of like general form, and it has the same rules, except the only difference is C is on the other side of the equal sign, okay? But you're still going to have A must be positive and no fractions. But I won't ask for it. I just want to point it out because you might see it in your travels, okay? Any questions so far? All right, well, let's try a few questions then. So here it says, write each equation in general form. So what we have to do is we have to move everything onto one side so it equals 0. Okay, so I'm going to move everything over onto the left side. So how do I move a minus 3/4 x? I added. So y equals plus 3/4 x. Pretty easy. Okay, how do I move a plus 5? Minus 5. So I go minus 5 and it equals 0. So all I'm doing is the opposite of add or subtract. It's pretty simple, okay? Now what rule am I breaking? What rule am I breaking? The fraction, right? I can't have a fraction. So what I do is I multiply by the common denominator. Now I only have one fraction, so my common denominator is simply 4. Okay? So the reason why I can do that is if I have a statement, okay? If I have a statement like 1 equals 1, if I multiply everything by 4 and I do it properly with my brackets, so I'm following my distribution rules, I'm still going to get a true statement. I can even multiply this thing by 2 now. And if I follow my distribution rules properly, I'm still going to get a true statement. So all we're doing is changing the appearance, just kind of like a fraction, right? If it's 2/3, well, that's the same as 4/6. Right? This one is just simpler. It's reduced. So this multiplying together with a fraction is not making a false statement. All it's simply doing is just changing the appearance. You guys okay with that concept? Okay, we're not making it different. We're just changing how it looks. So to multiply in properly, you have to multiply in to each term. So I multiply in, I multiply in, I multiply in, and I multiply in. Now, what's the easiest multiplication? the last one, because the last one equals 0. Okay? Let's start at the front. What's 4 times y? 4y. Okay, what's 4 times 3/4? Those cancel. We're left with 1 times 3, so it equals plus 3x. And then what's 4 times -5? -20. Now it's in general form, okay? X is positive and no fractions. Now technically you should write it as 3x plus 4y minus 20 equals 0, but I don't mark any of those wrong, okay? As long as x is positive, I'm okay if they're somewhat switched, okay? Is there a shorter way of doing it? Yeah, you could move the y over, but I'm always hesitant to do that because it kind of messes with your negative sign a little bit on the x, okay? Probably by the end of this little notes, though, you'll be ready for that. Any questions? All right. So the trickiest part that I find students struggle with is how to multiply into the fraction. Okay. So let's practice that. Okay. So first of all, we got to get rid of these brackets here. We can't start moving things across equal sign while we have brackets there. So multiply this -2/5 into the brackets to clear them. The y plus 4 doesn't change. What do we get? -2/5 times x, and then we get positive 6/5. Okay. So, you guys want to know the easy thing? We have to get rid of brackets somewhere, don't we? I mean, sorry, we have to get rid of the fractions, don't we? So why don't we get rid of the fractions now? Unless you want to go find out 4 minus 6/5. If you want to do that, go ahead. But then you'd have to get a common denominator and all that jazz. It's a lot of work. So let's get rid of our fractions first because it's going to be a lot easier. So let's multiply by what? 5. Okay, so equal sign should match, line up below. What do we get on the left side? 5y plus 20. What do we get on the right side? -2x plus 6. Ha! No fraction work to do. You're welcome. Okay, move the x term over. So what's the opposite of minus 2x? Plus 2x, so we're adding 2x both sides. And what's the opposite of minus 6? Sorry, plus 6. Minus 6. Kind of gave that one away. Sorry about that. So 2x plus 5y, you want to try and get in the proper order. So notice how I wrote the 2x in front, then the 5y, and then I'll have my constant terms, which is plus 14, and everything's off the right, so it equals 0. You cannot leave that blank. You must have it as 0. That is a number. Okay, if you leave it blank, you're telling me you don't know what you're doing. Not too hard, is it? Just a few tricks. Okay, let's try a few more then. Okay, so here we just have more complicated algebra. So let's change it into general form, and then we can change into slope-intercept form. So multiply to get rid of your brackets, first of all. Go ahead. Now what I'm going to do is write my answer. I'm going to kind of divide it up here, okay? So I'm going to write my answer over here. Okay, so then I'll move everything over. So move the plus x over by subtracting. Now we get 4x. Then I'll do my y's. Do I have to change my y's at all? No, so I'll put my y terms. Then I'll put my constants. So over here I have -15 and -5. That's -20 altogether. But then what am I doing? I'm going to be adding 10 to move it. So how many constants do I have? -20. What does the left side equal? 0. Everything's gone. Any questions about what I did there? Tyson? Isn't this negative 15? Isn't this negative 5? Oh, gosh, sorry, you know what? My bad, sorry. Negative 10. I was thinking, I should probably hoping I said it, but obviously I didn't. Thank you, Tyson. One brave soul. Okay, now I didn't screw up. Any questions about what I did now? Okay, I'm glad you guys caught that. Good work. All right, so now what we're going to do is change into slope-intercept. So over here, I'm just going to rewrite my general form. Okay, so 4x plus 2y minus 10 equals 0. Okay, so now I'm going to move the 4x and the negative 10 to the other side. Okay, so how do I move the 4x? By subtracting. And how do I move the negative 10? By adding. So you got to do the opposite. Always have your x terms first, your constants at the end. 2y doesn't change. Okay, so you notice in this first step, you're doing opposite of adding, subtracting. Okay, so always the first step will be looking to do adding, subtracting. And what's the second step? Dividing by the number in front of y. So now I'm dividing by 2. Dividing the entire right side by 2. So you've done this before. What do we get? Negative 2x plus 5. Okay. So you can graph this. You can't graph that unless you find your intercepts. Okay. But this one, the y-intercept, you can graph that quite easily. So just to let you know, when you have a line, there are points all over this line. Okay, so and it keeps going forever and ever. So there is infinite slope point equations, an infinite number. Right? They're all going to look slightly different, but they will always go into one slope point intercept. There's only one slope intercept, and there's only one general. That's it. Okay, and then you can go back and forth between them, but you can never go back up the slope point, because there's just so many different possible answers. Questions off the bro? Wait, example number 3. So find the intercepts when you're in general form. Do you guys remember how to do that? And that's grade 9 stuff. So x-intercept, what equals 0? I say x-intercept, which value is 0, x or y? We'll say something, it's a 50-50 guess, because I asked. Okay, you're right, y equals 0. All right, so you can then substitute that in. So we're going to get 5x plus 3 times 0 minus 15 equals 0. So do a little bit of algebra. 5x plus 0 minus 15 equals 0. 5x equals positive 15. X equals 3. Okay. So then find your y-intercept. Which value is 0 for your y-intercept? It'll be your x. So you get 5 times 0 plus 3y minus 15 equals 0. So now you're just doing some algebra to find your y value, your y-intercept. 0 plus 3y equals positive 15. I just move my 15 over. 3y equals 15. y equals 5. Okay, so you can then go and graph that, right? So your y-intercept is 5, 1, 2, 3, 4, 5. And your x-intercept is 3. Boom, now you got a line, okay? Now we don't have to graph it, but you could easily. Any questions? So, example number 4, go ahead, find your intercepts. Find your x-intercept so we can graph this line. And find your y-intercept so you can graph this line. Go ahead. I just showed you how to do it. Do it on your own now. Okay, so there you have it. Now the tricky one with this question is right here. What is 0 minus 2y? Well, if you're at 0 and you're growing negative, you're going to get negative 2y. And so at the end, you're going to divide by negative 2, which means y is negative 5x. Okay, so that's the tricky one with that equation. So if you're going to, kind of think, oh, it's just this, it's always this answer, it's always this divided by 5. Well, Mr. Barker is super old and has done this like 1,000 times. I still do my little bit of work so I know that it's positive or negative 5, and just be careful with it. Okay, you got to be so careful with these ones. So I'm going to throw in little tricks to make sure you're doing your algebra properly. So you just got to take the time to do the algebra properly. Okay, so now you can graph this. So go ahead and graph it. Y equals negative 5 is down below. X equals 2 is there. So your intercept here is 0, comma, negative 5. This intercept here is 2, comma, 0. So we haven't found lines, we have found points. That's important to know. Okay, we found point values. So then we have our 2 points, and then you can make your line. Okay, so I don't want you thinking that those are equations, because they're not equations. They're the point values solved by doing the algebra. Okay, and so you should identify which line that is. That is line A. So you should put either the question number, the letter number, or the equation on either the top or the bottom of the line. All right. Okay, go ahead, graph the next line. This is different now because this is now an equation. Okay, so when we have a special equation, it's saying that the line crosses at x equals negative 7. So there's x equals negative 7. In order to cross the axis at that point, it's got to be a vertical line. Okay, so we here are graphing a vertical line right along x equals -7. And so that's line B. Okay. You guys understand the difference there when you're finding intercept point values versus when you have an equation? Okay. It's kind of important to see. Questions, comments, concerns? So in real life situation, where you cross the axes has a lot of meaning. It helps you solve the real world problems, okay, which we're not going to touch too much on this year, thanks COVID. But you can apply that stuff to a whole bunch of business decisions, life decisions. In fact, you use that stuff when you go to the mall and decide how many shirts and shorts and outfits to buy, different types. You just don't realize it, but that's kind of what you're doing. Okay. Any questions? All right, next one. So now we're just going to play around with the perpendicular slope idea and parallel lines ideas. So we're going to put those together. So the question is, if you have a perpendicular line, it's perpendicular to this line, you have to find this slope. That's what the question is telling you to do. It says find the slope, because then you'll know the perpendicular slope, which is what we're using that goes to that point, so you can make your equation. Right? So there's a lot going on here. So what we're going to do to find the slope is we're going to turn this into y equals mx plus b, because then we'll know the slope for sure. Experts, you'll probably be able to do this by looking at it, but right now, let's turn it to y equals mx plus b, okay? So how do we do that? Well, let's move the 3x over. The -2y is going to stay. Okay. Let's move the 3x over and the -12 over. If you don't feel like doing two things at once, you can do it one step at a time. That's fine. So again, you're going to do the opposite of what you see. So minus 3x plus 12. Okay. Always adding, subtracting first. We're doing reverse BEDMAS when we're moving things. What are we going to divide by now? -2. And everything on the right gets divided. So we're left with y equals what? Good. Positive 3 over 2x, -6. Okay. So what is our slope? The slope is 3 over 2. That's from the line that's perpendicular. So let's just look at one thing. What numbers gave us our slope? Kind of these two, right? The one in front of x and the one in front of y. So if you look at it, if we have ax plus by, okay, those numbers kind of gave us our slope. But this number here is -2. Oops, sorry, 3 and -2. That's not our slope, is it? What would we have to do to make that our slope? Add another negative sign, because that would make it positive 3 over 2. So our slope, our slope actually equals A divided by B, but add a negative sign. Okay. This here will be the shortcut for experts. Now, if you just didn't understand what I said, who cares? You don't need to. Why? Because if you turn to y equals mx plus b, you'll always be able to find your slope. Okay? So you don't need to know the shortcut, ever. I only point it out because it's cool. So, what slope are we going to use then? Our line that we're going to create is perpendicular, so this should be not 3 over 2, but perpendicular slope is, flip it, and make it negative. So -2/3. Okay. So that's the slope that we are going to use. and we're going to use this point. Okay. So y minus y1 equals mx minus x1. Okay. Go ahead, put it into the equation. See what you can do. Put it into slope point form. Go. Turn to slope point. And once you're in slope point, we're going to go into general. Okay. So you got the slope, you got the point, put it in there. Okay, so there's my slope point form. Now you got to multiply to get rid of your brackets. Okay, multiply to get rid of your brackets. Okay. Now that your brackets are gone, let's get rid of our fractions. So multiply the whole thing to get by a common denominator to get rid of your fraction. Okay, for the point -1. Yeah, you good? Okay. Okay, so I kind of want to do something a little bit different here just to show you a little trick, okay? Sometimes you're going to get a negative x, right? So, should I do it on this question? Yeah, I'm going to do it on this question. I'm going to move everything to the left. Actually, I'm not going to show you on this question because I think it's going to be too confusing for you. I'll show you the trick in a second. So I'll move my -2x over, becomes positive 2x plus 3y. Move my -2 over, I get -13 equals 0. You guys are all good with that? Okay. What if, though, what if you had something like this? What if you decide to move everything over to the left side, the right side? And so you had -2x minus 3y plus 13. That's okay, except what do you notice about x now? X is negative. Are you allowed to have negative x? No. So what you do is you multiply everything by -1. Now you're going to do this more and more in our next unit as well. That's kind of why I'm showing it to you. So when you multiply everything by -1, it's just like it was before. You're multiplying all the terms. And so what happens is your terms just change signs. Okay. And now you can see they're exactly the same. Okay. So if x is negative, multiply by a -1. And then what happens is your signs change. Okay, In our last unit, we're going to be doing that a lot where we have to change the appearance just to make it what we want it to be. Okay, just a little algebra trick that you use quite a bit. Any questions? Okay, so scratch this one out. This is a real world question. We're not going to do it. Okay. This one here. So this is just a little, this kind of plays along with the idea ax plus by, and then m equals negative a, because a has to go to the other side, divided by b. Okay. And so this has to equal 3 over 2. Okay. So from this, we would get, move 6x to the other side, you would get a negative 6, and then you divide by a b. Do you want me to show you the long way? Okay, the long way, okay, I'll show you what's happening here. You would go minus 6x minus 5. Then you get by equals 6x minus 5. Okay. So I'm just moving everything to the right side. And then I would divide by b. So divide the left side by b, divide the right side by b. And so y equals negative 6 divided by bx minus 5 divided by b. And this is our slope. That's what we care about. So this slope, negative 6 divided by b, must equal 3 over 2. So what could it be? What could b be? Well, how would you go from 6 to 3? Yeah, you would, or sorry, to go from 3 to 6, you would times by negative 2, right? So what would you have to do here? Times by negative 2. So b equals negative 4, okay? So you can use the equivalent fractions idea to figure it out. So that's kind of a weird question, but more for the experts, okay? It's more for an expert's question. Number 8 is more for an expert question as well, all right? So what type of line has a equals 0? So what you would get if a was 0 is you get a plus by plus c equals 0. So you would get something, right? There would be no x term. So you would get a line that's something like y equals some kind of number. You don't know what the number is. Let's pick a number. For an example, pick a number. Who wants to pick the number? Eeny, meeny, miny, mo, I pick Courtney. 3. So if you have y equals 3, graph that real quickly. On my grid, just graph it, right? You're going to apply your knowledge. You're going to make an educated guess. Y equals 3, that means you cross, right? You cross at y equals 3. So here's y equals 3, and you cross it there. So what type of line is that? Well, that's a y-intercept. That's the point. But we're talking about the entire line. It's not vertical. It's horizontal. Okay? So this is a horizontal line. So usually when they say what type, it's like horizontal, vertical, or oblique kind of thing. All right, again, that's a higher level question. All right. One thing to keep in mind, number 24, it's an important question. It's saying which ones are the same line. So for number 24, you got to turn them all into general form. They're all different types of forms. You can't tell. Turn them all into general form, and then it's going to be really easy to see which ones are the same. Okay, that's how you do question number 24. Now, you could also turn to y equals mx plus b. That's just a bit more work. I would go into general form. Turn to general form. You can tell right away what are the same, which ones are different. Okay. Any questions?